Okay, so the present part, the last part of the video, what we're going to do is look at our electric bill. Okay, our electric bill. And how do we compute our electric bill? Okay, so we have problem one, we have our impedance, our starting point's impedance. Page two, we did our current. Okay, page three, and I'll mark page three, we did our power. Okay, now from page three, we find our electric bill. Okay, how does that work? Well, let's just do our rate. So we have a basic electric bill rate. Our electric bill rate is always going to be cents per kilowatt hour. That's just how it is. Okay, it's always cents per kilowatt hour. That is, if any electric bill is this. So we just say it's an expensive 20 cents a kilowatt hour. Roughly, it's probably like 11, 12 cents. We don't know. And our time duration, right? So hour is our time duration. So I can say, okay, we're going to leave the duration is going to be, let's say, 30 days. Okay, it could be longer. Okay, we don't know. So here, what's the first thing we do? Okay, first thing we do is we do not jump to our power. We do not want to do that. We want to make this conversion clean. Okay, so first thing we want to do is solve for time. Okay, and time we need hours. Okay, we got to get that rate down. So we get 30 days, right? And how do we get hours? Okay, so we get days and hours. So we want to eliminate days, so we have days on the bottom. That eliminates, and that's 24 hours in one day. So now you have your setup. You simply cancel this out, and you multiply 30 times 24. It's 720. You get 720 hours. Okay. Now let's look at our rate. From our hours, we're starting to look at our rate, and our rate, basically, our bill will be at 20 cents per, and that's cents, by the way. I just want to kind of mark that out. Cents per kilowatt hour. Okay, and at 20 cents per kilowatt hour, how do we make our conversions, right? So we have to have cents by itself here. Once we get cents by itself, we can get the dollar. But clearly, we have to have the monetary amount on the top and eliminate the bottom. We're going to eliminate everything on the bottom. How do we eliminate the bottom? We eliminate the bottom by having the same unit on the top. So first thing we're going to eliminate is hour. Okay. The second thing we're going to eliminate is obviously kilowatts, right? So we have to have a kilowatts on the top. And so let's just look at that. Let's just start that now and then see where the problem goes. So obviously this is going to be 720 at something kilowatts per watt. Well, that's 1 kilowatt for 1,000 watts. Okay, so here our hours go just like that. Our kilowatt goes just like that. And now we have cents over watts. I have to get rid of my watts. This is where our power comes in. Okay, our electric bill is in watts or VA. Now understand, watts and VA are really the same thing. Okay, P is equal to VI. VI, so you have watts and amps. Now, why do we call, volts and amps. Why do we call it watts? Because you differentiate between total power and real power. Our electric bill is not on our real power, it's on our total power. This is how much we're using, but this is what we're paying for. Okay? Understand the difference. We're billed on we're billed on the total, but we only use this. Okay? So our electric bill is really going to be about 66.2% efficient. Right? This is how it works. So we take our total power and multiply out to get our electric bill. So we get here 47.7 VA. All right, so let me write out VA. Okay, here. And that VA is really what? VA here. Okay, that's the same thing. And so we simply cancel that out, and we get the following. We get 20 times 720 times 47.7 divided by 1,000. And here, 20 times 720 times 47.7 equals just like that. So we got what? 686 cents for running, let's say, something that runs at 0.79, something that's running at, how is this is such a small electric bill, right? Why is this 686 cents small electric bill? Because remember, we're using 0.795. So this is like if you left your one of your lights on for 30 days straight and didn't turn it off, you're paying this much extra. So reality, this will be closer to 10 or 20 watts. I'm sorry, 10 or 20 amps of total current, and then that would obviously change that number, right? So how do we get this number down to dollars? Well, you simply have 686.88 cents, right? And you want dollars here. So you would say, okay, it's 100 cents. I'm sorry, let me erase it real quick. Okay, it's 100 cents per $1, right? So simply you'll have 686 divided by 100. So we can just do that number here. It's really easy. 686.88, divide that by 100, and if you probably won't even need a calculator, but $6.87. So here, the money that you're going to pay off the electric bill for running one of your lights for 24 hours is $6.87. Okay. Now, obviously, in total electric bill, if you kept everything on, we're looking at, if you have maybe 20 lights in the house, then we're looking at 20 times that. If you leave everything on, right, we're looking at several hundred dollars of electric bill. Okay, so this is how you handle this.